Hi everybody, welcome back. I'll be uh, trying to explain a few problems on probable permutation and combinations, uh, which are very important. Okay, so let us do that. Now, if I have, uh, there are 50 soldiers. Okay, if there are 50 soldiers in a guard in which there are 36 and remaining 20 are Gurkhas, 36 and remaining which are Gurkhas. Okay, uh, the captain wants to select one of them as the commander of the guards. So, how many different ways he can do it? Okay, so on a whole, we have 50 such soldiers, right? So 30 ways he can select as a sick soldier, and 20 from the Gurkhas. So hence the total number of ways he can do as 20, 30 plus 20, which is 50 ways he can do. Okay, let us see the next problem. There are three trains, okay, four buses and two planes uh, to travel from Chandigarh to Delhi. How many different ways a passenger can travel from Chandigarh to Delhi? Okay. Now, the given data, which are three trains and two for three trains and four buses and two planes. So we can add up all those values which is given. So 3 plus 4 plus 2, which is 9 ways uh, the passenger can travel from Chandigarh to Delhi. Okay, we'll see next one, next example. Let us find the number of numbers from 1 to 150, both inclusive, okay, which are divisible by 2 but not 5. We have numbers from 1 to 150, okay, which are divisible by 2 but not by 5. Okay, so what will be the answer for this? The number of numbers which are divisible by 2 without any restriction, that is not inclusive, so it should be 75. Okay, then the number of numbers which is divisible by both 2 as well as 5 will be 15. Okay, so we have got both values with without any restriction divisible by 2, and the number which is divisible by both, that is 2 and 5, is 15. So the result would be 17 75 minus 15, which is equal to 60. Okay, fine. Let us try to solve the next problem. So if I have the number of three digits, okay, numbers containing the digit 7 exactly once. So what will be the solution for this? The number of three digit numbers, the number of three digit numbers containing the digit 7 exactly once. So what will be the solution? So you have 799 and 879 and 8979. So this results to 81 and 72 and 72. So this I get the result as 225. Okay, so that is the answer for that. Okay, Let us move on to the next problem. Okay. Now, if you consider all the 5-digit numbers, okay, uh, where each of the digit is chosen, each of the digit which is chosen from the set. The set would be consisting four elements, that is 1, 2, 3, and 4. Okay. Then the number of numbers which contain all the four digits. What will be the answer for this? So we have a set which consists of four elements. So n will be 4, the number of possibility, and corresponding to that is 4c1 into 5 factorial divided by 2 factorial, which leads to 240. So the result is 240. Okay. Let us move on to the next problem. Okay. How many ways are there to arrange the letter garden? Okay, the garden has got 6 letters in this word with the vowel in the alphabetic order. So, so n will be 6, and uh, we need to arrange that. Okay, in that vowels we have a and e as the vowel here. So you have uh, r value, which is 2. So 6c2 into 1 into 4 factorial, which leads to 360. So this is the solution for that. Let us move on to the next problem. Okay, a student is to answer 10 out of 13 questions. Okay, in an examination such that he must choose at least 4 from the first 5 questions. Okay, the number of choices available to him. So what will be the choices? So uh, the total number, which is 13. Okay, the total number, which is 13. So, and out of which he answers is 10. Okay, so he must choose at least 4 from the first 5 questions. So we have the combinations as 5c4, 8c6. Okay, that is the first one, and the next one is 5c5 and 8c5. So that results to 5c4 multiplied with 8c6 plus 8c5 multiplied with 8c5. So that results to 196. So that's the answer for that. Okay, please write some comments on the uh, discussions which we have done. If you are not able to understand, we'll discuss this again once again. Okay, since we can go live at any time. Okay, so let us further continue to solve some of the problems on permutation and combination. So I have again, if I take one example, there are 3 trains, 4 buses, and 2 planes to travel from Chandigarh to Delhi. Now, I have again extended this problem. In how many different ways a passenger can travel from Chandigarh to Delhi and again return back? So, how many ways we can do that? So, this is very interesting, and it can be solvable. Yes. So, here the number of ways: 3 trains and 4 buses and 2 planes. So if you add all these again, we get 9 different ways. We have done this earlier. Okay, and again he returns back. Okay, so returning back again 9 ways. So you have to add up, you have to multiply these two values. So 9 into 9, which results to 81 different ways. Okay, let us see one more example. Okay, let me read out once again this problem. There are three different, and there are three trains, four buses, and two planes to travel from Chandigarh to Delhi. In how many different ways a passenger can travel from Chandigarh to Delhi and return back? So that was the question was all about. Now we have solution for this. So the solution would be from Chandigarh to Delhi. We have 2 plus 3 plus 4, that is 2 is for 2 planes, 3 is for 3 trains, and 4 is for 4 buses. So we have 9 such ways. And again, getting back again, that is also same. So that was 2 plus 3 plus 4, which is 9. So to complete the journey and coming back, so that can be put together, that is 9 into 9, which is 81 ways. Okay, so let us move on further. Let us look next example. In a conference room has got 10 different entrance doors, okay, and 5 different exit doors. We have 10 different entrance doors and 5 different exit doors. In how many ways these delegates can enter into the hall and come out once? So what is the solution for this? So delegates have got 10 ways to enter, since to enter the conference hall, and since they can come out only through the exit door, so that would be again 5. So 10 into 5 is 50 ways. So to enter we have uh, 10 ways, and for exit we have only 5 different ways. So 10 into 5, so it would be 50 different ways. Let us see next example. Okay, let us see a set, okay, which consists of 1 to 22. The set has got 1 to 22 numbers. Okay, if you consider that set as A, and I have another set which is B, which is a subset of A, and it has got this B set B has got exactly 11 elements. Okay, let us find the sum of the elements of all possible subsets of this. Okay, so the number of ways would be 11 factorial into 2 to the power of 12, because you have two sets, so that's why you consider A and B. So that's that. Now let us see next example. Okay, now let us find the number of ways in which 6 rings, okay, we have 6 rings. The number of ways in which 6 rings can be worn on the four forefinger of one hand. Okay, so what would be the answer for this? Each ring have got 4 options to go, so it requires 4 to the power of 6. So 4 to the power of 6. Okay, that will be the solution. Yeah. Okay, now let us see one more example, so which would be easier to understand. Now suppose if I have a basketball team, okay, consisting of 12 pairs of brothers. A basketball team consists of 12 pairs of twin brothers. On the first day of the training, all 24 players, all 24 players stand in a circle in such a way that all the players of twin players are neighbors. Okay, what would be the number of ways which can be done? Okay, so let us see the solution for this. So the number of ways which can be done as 11 factorial into 2 to the power of 12. So we have that much. Uh, okay, so that is the solution for that. So 11 factorial into 2 to the power of 12. Okay, now let us see some more problems. Now, suppose if I have the if I can consider uh, if I have the problem like this, write all the combinations of four players A, B, C, and D. Okay, you can name it as you like. So if I have the players which are A, B, C, and D, okay, uh, taking at a time, what would be uh, the combinations of these four players? So the combination would be A, B, and C, like that, and B, C, and A, and so on. So the combination would be 4C3. So that would be 4 factorial by 3 factorial into 1 factorial. So that is the result, that is equal to 4. So that results to 4. Okay. Now, what would be that is A, E, I, O, U? I'll not consider U. A, E, I, O. Using 3 at a time, using 3 at a time. So the combination would be AEI AIO, and so on. If I do all those combinations, I'll be having 24 such, that is 4P3. Okay, so that is the result. So those are the good examples which we can consider it. Okay, further, let us if you have any queries or comments, please do write. Okay, I'll be answering few of the questions which I have got as a query. So let me write it down. Okay, okay, you can send your queries through mail. Okay, email. Okay, let us try to solve the next problem. Now, how many nine-letter words can be formed by using the letter of the word producing? Okay, Producing, producing. So which has got again, uh, we have that is also has all got nine different letters. So 9 so nine different ways. So that results to if you have that in the results, so that would be 9 factorial ways which is can be done. Okay, so let me continue on the problems now from a different novel, and from three different dictionaries, four novels and one dictionary are to be selected and arranged in a row on the shelf so that the dictionary is always in the middle. Then the number of such arrangements can, what will be the number of arrangement of such arrangements can be done. Okay, we have six different novels and three different dictionaries. Four novels and one dictionary are to be selected and arranged in a row. Okay, that's the question there. So the number of ways in which four novels can be selected is 6C4. Okay, different novels which we have as six and four novels to be selected. So 6C4. So that is 15. 6C4 is 15. The number of ways in which one dictionary can be selected, that is 3C1. Okay, so it is 3. Now, four novels can be arranged in four different ways, four factorial ways, and the total numbers, which is 15 into 4 factorial into 3, which is also 1080. So, that is the solution for the problem. Okay, fine. Thank you for listening. Please do write to me.